Well, hello everyone, and welcome to another live viewing with your girl Audrey Codner from ACG Math Tutoring. So, we are really coming off from a busy day, a busy high. A lot of people are reaching out, which is awesome. So we're going to do a little bit of graphing. So we're going to be looking at our exponential functions. So some people are kind of working on this right now. Some people are not quite there yet, but hey, why not be ahead of the class versus trying to catch up? So here we go with the exponential functions. So an exponential function is in this form. It's y equals a times b raised to the x. Now, your a value, that's always your starting point. So as we always say, especially for linear equations, your starting point is always your y-intercept. So guess what? Your a, that is your y-intercept. So that's going to help you when it comes down to the graphing. So your b is the factor rate. So if you think about like when you're doing simple interest, well, not really simple interest, but when you're doing interest problems and it says it's an increase or a decrease, there is a growth or a decay, that's where you're looking at. You're looking at that b. Sometimes the b is inside a parenthesis. Sometimes there's like a multiplication sign, a dot that's in between the a and the b. Or sometimes they just have it put together just like that, okay? So no matter what, your factor rate is going to be that b. So if you're looking at, let's say, a table and you're noticing the problems are increasing by multiples of 2, that means you're putting your 2 right here for that factor rate. And then the x is always sometimes your time. So is it happening in 3 years? Is it happening in like 30 minutes, 20 days, all this other stuff? That's usually your exponent. So you're looking at your terms. So when we're looking at your domain, this is key. Just like with the quadratic functions, your domain is the set of all the x's that's on the graph. And your domain will always be all real numbers, okay? When we look at the graph, we're only going to look at a small snapshot of that graph, okay? You hated this in school. It's all right, Maisha. We're going to get through it, girl, okay? But at the same time, we're going to breathe. We're going to relax. We're going to get this done. All right, so your domain is the set of your x's. No matter the graphs, your domain is always the x's. Now, your range, so I'm going to highlight that, your range is your y's. So when your range comes into play, you're either going to be looking at it from a perspective going to positive infinity or you're going to negative infinity. All right, so you're always dealing with positive real numbers. That means it's going up. And then negative real numbers, that means you're going downwards. Okay, so those are your two choices with range. And that's very consistent. Okay, so domain, all real. Range, you're either going up or down. Now, this is a term that I'm going to slide over that you probably heard sporadically here and there. And especially when you get into more of the advancement, you have something called end behaviors. I should put plural, okay? Your end behaviors. So basically, it's what's happening to the ends of your graph. So are they both going up or are they both going down? Is one going up? Is one going down? So it's always like what's happening to those end parts of your graph. So like if I ever look at, I'm going to try to pull an example that we did once before, especially with quadratics. Tra-la-la-la-la-la-la. Shouldn't be too long ago. I mean, we did quadratics like last week. And all of a sudden, when you want something, you can't find it. This is what happens when you do a lot of work. But that's all right. Work is good. Oh, seriously, where'd it go? Oh, wait. Here we go. is what happens. So if I take a look at this graph here, this is quadratic because it's giving me my U shape, aka the parabola. Okay, so my parabola was opening up like a cup. So when I talk about end behaviors, we want to know what's going on with the ends of my graph. Both of them are going upwards. So some of them will say, as your x value is approaching positive infinity, okay, so as my x's are going this way, my end behavior is going up. So that means my y's, or my function of x, is approaching positive infinity because it's going up. Okay, so it's always talking about the end behaviors. So I always like to say this is an up-up situation. So that means as my x is approaching negative infinity, that's going to the left, my graph is going upwards. So that means my y's, or the function of x, is also approaching positive infinity. For the y's, remember, they're going up or down. If everything is pointing up, they're going all the way up to positive infinity. Okay? If I look at this graph, I'm looking at the end behaviors. What's happening at the ends of my graphs? So I notice that the ends of my graph, they're both going down. So we got a down-down situation, right? So that means as my x values approaches positive infinity, so as it goes to the right, because this is positive infinity, my y values are going down. So that means my y values are going down to negative infinity. So if I take it the other direction, as my x is approaching negative infinity, that means as my graph is going to the left, my y's are also going down. So my f of x is going to negative infinity. Okay? This is how you list out your end behaviors. So I'm just basically telling them my x is either going positive infinity or it's going negative infinity. You just have to tell me what's happening to the y's. Well, my y's are going down either way. So we got a down-down situation compared to our up-up situation. Okay? With quadratics, you're either going both up or you're going both down. All right? Okay, how are we doing? Was that gibberish for you guys or what? End behaviors or end my behavior? Stay tuned. Oh. Okay. So end behaviors, it just basically talks about what's happening in the ends. Functions and graphs killed me freshman year. Oh. Well, let me see what we can revive you. So, that's with the quadratics. But what we're going to do today is look at exponential. Okay? So we're going to take this step by step. If we get to end behaviors, awesome. If we have to save end behaviors for, say, tomorrow or later on tonight, we can do that. All right? So now, let's just talk about graphing. Okay? That's the best thing about coming to my sessions is I'm not going to force too much. I just want you to get one piece and understand that one piece. So I want us to graph y equals 3 times 2 raised to the x. Now, right now, if I just tried to go ahead and graph it, yeah, that would be a little intensive. Say that I have a graphing calculator and all of a sudden the batteries just died. So now I have to do it. So this is what you can do. Let's create a table of values. Let's not be too crazy, okay? Let's just create a table of values. I'm going to substitute some numbers for x, and I'm going to put it on my graph, okay? I only need a couple of points, 2, maybe 3 at most. So we don't have to do 5. We can actually do 3, and that will help us. So if I do so, I like to have at least, if possible, like 1 negative, a 0, and 1 positive, okay? This is like the staple that I like to use. I want to keep them small because remember, exponential, it can start pretty slow and then takes off, right? And you're like, holy hell, think about it. One person got sick in COVID. And then look at what happened. Massive expansion, went everywhere. It's just crazy, right? Or even just think about like when someone gets sick in your class. All of a sudden they're sneezing and they're like disgusting because no one wipes their hands and goes to the bathroom, get themselves situated. Oh no, they want to touch each other. It's kind of gross. But one person gets sick and then next thing you know, the next day, 2 people are not feeling well. Then the next day, 5 people are absent. The next day, like 10 people are absent. All of a sudden, there's no one in class except for the one kid that was originally sick, which just cracks me up. So it's always something that it starts small and it grows rather quickly. So we're going to substitute in for the x. So my equation for the expression is going to be 3 times 2. And instead of an x, I'm going to put a negative 1. Now, the one thing that we need to know about negative exponents, okay, we have to drop it or flip it to make them positive. But what's being raised to the negative 1 is the 2. So in actuality, this is what's happening. You're going to have 3, which is going to remain in the numerator, but this 2 to the first power, that's going to drop down in the denominator. So 2 to the first power is just 2. So in actuality, you have 3 over 2, or, for all my decimal people, 1.5. So your point is going to be at negative 1, 1.5. So that's one of your order pairs. So now let's try it with the 0. I'm going to see if I can change colors so you can keep up a little bit. So we have 3 times 2, but it's to the 0 power. Now, anything raised to the 0 power is what? Anything raised to the 0 power is what? Yes, Ms. Audrey, thank you. Okay. Yes, we got 1. Yes, Lisa Kick, watch out. Okay, so anything raised to the 0 power is 1. Okay, it's always going to be 1. So we actually have 3 times 1. Okay, so when it comes to the exponentials, there's always a start, and the start is going to be 1. So 3 times 1 gives me 3. So now we just found another order pair at 0, 3. Now lastly, one more time. Okay. Yes, this is exponential function. Alex, hello. All right, so we have 3. And we have our b, which is 2, but this time we raised to the first power. So 2 raised to the first power, that will give me my 2. Because make sure you're not multiplying 3 and 2 and then you're dealing with the exponent. No, 1, you're making it way bigger than it has to be, okay? So the only thing that's actually being raised to the exponent is the 2. So just this section. Okay. All right. So then 3 times 2, that will give us our 6. So we have our order pairs to put on our graph. So let me unzoom just a hair. Okay, that was more than a hair. But we have our points. So we have, let's say we're counting by ones. Let's just make that easy for us. So starting here at the origin, I got my -1 and I go up 1.5. I started my origin, I got 0, 3, so I don't need to go east or west, I just have to go up 1, 2, 3. And then I have 1 and 6, starting at my origin, going to the right 1 and up 1, 2, 3, 4, 5, 6. And you're like, ooh, okay, I'm starting to see a little bit of a curvature. Now, you're probably like, well, does it cross the x-axis? I don't know if it crosses the x-axis, or can I figure out a way to find out if it does cross the x-axis? We could. If you want, let's see if I can, I'll just use a pencil. Let's see if we can get to -2 and see where that will take us. Okay, so this was -1. Let's see where -2 will take us. All right, so I'm plugging in. So I have 3 parentheses 2, -2. So that means the 2 is being raised by that -2. So my 3 is going to stay in the numerator. And that means 2 to the second power is going to drop into the denominator. So that will give me 3/4. So if I'm here, where's my pen? Here we go. So starting at the origin, go over -1, 2, and that means I'm going up 1/3 of the way. So it's about here. So I'm starting to get the notion that if I keep going, my numbers are going to get smaller. But will it ever cross the x-axis? Okay, Ms. Goddard says that that the end, I can't, why all of a sudden I can't say it? All of a sudden I can't say it. Okay. So there is a boundary. I really can't say it. I don't even know the word. I need sleep. Okay. I really do. So there is a boundary that if you try to get as close, you can get as close you can for 0, but it won't cross it. It will get as close as 0.0000000009999992222, but it will never equal 0. Why all of a sudden I can't say it? Because there isn't anything added after the decay part of the formula. Yes. Okay. So it's actually going to look relatively close to this. Watch, as soon as I finish the live, that's when I can actually say the word. And that's so weird that I cannot even say the word. That's weird. Why? Why am I brain dead? Asymptote. There we go. Whew. I'm telling you. Literally, I had a major brain fart. Asymptote. It's not that hard. I mean, I just left the tutoring session, so I'm like, okay. Now, as I mentioned, my domain is always going to be all real numbers, okay? because we're only seeing a small snapshot. Like, even though you're like, oh, well, it's kind of right there. Yeah, because we're only seeing small bits of it. It's going to go up and slowly but surely in small bits of it. It's going to go up and slowly but surely go out. Okay? So it's always going to be all real numbers. But my range, my y's, since it's not crossing my x-axis, I have this boundary. Okay? It's only dealing with what's going on from the 0 all the way up. Not including 0, but from it all the way up. It's not dealing with any of the negative y values. So if you want to write your range, I'm going to write it in intercept notation. We're looking at 0 as our starting, but we're not including 0 all the way to positive infinity. Remember, your lowest number always comes first. If you don't like it this way, and some teachers rather you use the y or the f of x is greater than 0, it could be written as such for the inequality phrase. Okay. All right. Oh, thanks, Lynette. What's the daily heart? I know. It's kind of crazy. There's so much about TikTok I gotta learn. But right now, I couldn't even remember asymptote. Like, how can I keep up with a freaking heart? I'm losing my mind. All right, so we'll worry about the end behaviors next time. I just want us to at least get this. All right? I just want us to at least get this. Now, so when it comes to the next one. Okay, so this time we're going to graph -2, 1/2 to the x. So I know right away a lot of you guys are like, oh, yeah, I can go ahead and just say it's going to be a decay. And I always ask how you know that this is going to be a decay, a decreasing. And they're like, oh, because the 2 is negative. No. I know that this is going to be decay, not because of the -2, but because what my b value, remember the b is always going to be the one that's adjacent to your exponent. Because my b value is between 0 and 1, I know it's going to be decay. Okay? Right? I love how I can laugh at myself. It's been a long night. It's been a long day, actually. All right, and it just started. So, in order for us to graph it, let's keep it simple, right? Let's go with a table of our values. Don't have to get too crazy. I like to use at least one -1, okay, a 0, and a 1. All right. So we're using our function, and this is what I didn't put for the other one. Our 1/2 raised to the x. Let me put it in this other one. So all we're doing is replacing this 1, the -1 for the x. So we have -2 times 1/2 raised to the negative first. Okay? The only thing that's being raised to that negative exponent for right now is the 1/2. Okay? Don't multiply the -2 and the 1/2. So anytime we have a negative exponent, we have to flip. Okay? We have to flip. So I keep that -2. So instead of a 1/2, it's going to be a 2/1 raised to the first power. And 2/1 is just simply 2. Okay, so we flipped that 1/2 to 2/1 so we can get a positive exponent. Now 2/1 is exactly the same as saying 2. And now we got to multiply -2 times 2, which gives me a -4. So we have a point, -1, -4, that's going to be on that graph. Okay. Same is occurring for the next one. We have -2 times 1/2 raised to the 0 power. So anything raised to the 0 power is not 0. It is 1. Okay? So since that 1/2 is being raised to the 0 power, we have -2 times 1, which is simply -2. Okay? All right. So how are you feeling now? The one that says, OMG, I never understood this. Star symbols. Okay. So when you want to graph it, just make yourself a tiny graph. Okay. So now, just need to get more studying in because I have to do GED test next week. Okay. All right. Well, thank you. All right. So now, okay. Next one, we can do -2 times 1/2 times, or raised to the first power. So anything raised to the first power is itself. So you basically have -2 times 1/2. So you know your answer is going to be negative, but what's half of 2? And it's a 1. So you found order pairs. We only need roughly like 3, maybe 4. You know, some people like to say 5. But if you can get a gist of how the graph is moving, we can kind of work it from that way. Okay? So now, let's plot our points. We have -1, -4. Let's see if you guys can see it. Okay, starting here at the 0. I'm moving to -1, then moving down 1, 2, 3, 4. Plot my point. Okay. Starting at the origin at 0, the next point is 0, -2. So I'm starting, I don't have to go left or right, I just go down 1, 2. Starting at the origin, the next point is 1, -1. I go to the right one and down 1. It's really small, but I'm starting to see a little curvature. Let's see what would happen if I put, like, say 2 as my exponent, just so I can see the curve a little bit more. Like, is it going to cross the x-axis? Something. Because sometimes that's what we do, guys. We just, like, try things out. Okay? So we have our 2. So we have -2 times 1/2. Square it. Equals. Now the 1/2 is being squared. So I bring down my -2. And since I'm squaring that 1/2, that means 1 is being squared, which gives me 1. The 2 is being squared, so that's 2 times 2. That gives me 4. Okay? So this is exactly the same as saying -2 over 4. Okay? So when I multiply the whole number with the numerator. That's where the -2 came from. And then I can bring the -4 over. Because if I made this whole number into a fraction, I can put a 1 underneath it. And it's not going to change the value of my -2. But this, both 2 and 4 are even, so it can be reduced to -1/2. So the next point at 2 is going to be -1/2, which is right about here. All right. to the power cannot be negative. Okay, good. All right. Hey, film artists. How are you guys? All right, good. So now you're starting to see there's a little bit of a curvature. Okay, so if I'm coming here, coming from the bottom, now we're here. All right, so do I think it's gonna cross the x-axis? Do you think it's gonna cross that x-axis? Put it in chat. Oh, sorry. Okay. Okay. Let's say no, maybe not. Nope. Okay. No. Oh, hey, Pi. All right. So it's not, because it's called my asymptote. There we go. I'm okay. So basically our x-axis is acting as an asymptote. So an asymptote is like a boundary. So it's going to get as close as it can to it. All right. But it's never going to equal 0. All right. So if you notice, and this is one thing I didn't mention about the last one. Remember I said your A value is your y-intercept? So our A value is our number that's in front. This was at -2. Take a look at our y-intercept. It was at -2. The previous one, same thing. So we have 3 times 2 raised to the x. 3 was supposed to be my y-intercept. 1, 2, oh. There's your 3. There's your y-intercept. So your A is always going to be your starting point. So if you ever get anything like, oh, I don't know where to start, that's where you can start. Okay? But I think it'll be so much easier as well if you know where to start. Okay, I know where 0 is going to be, so I might not have to use that calculation. But let me see what's happening 1 stroke below it and 1 stroke above it, meaning what's happening at -1 and what's happening at 1, to kind of help guide you for the sketch of your graph. Okay, so sometimes when you have these timed assessments, they don't really care about their full dissertation. They just want to know, what does the graph look like? Is it A, B, C, or D? Okay, go ahead and sketch my graph. But no, good. Okay. All right, well, thanks, Farmer and me. All right, so now let's take a look. What is my domain? What is my domain? What did I say is our domain? And it will always be that. What would be my domain? Thank you, Miss Carter. It's like all real numbers. Yes. All real, all real. Hey, Chris. Thank you, Clay. Yes. I'm in nine breath. Oh, 9th grade. I was like, 9 breath. What is that? We're doing grades by breath? My gosh. Okay, excellent. Good job. Shouldn't you be in school? Or is this lunch? It's like, I forgot. Not a problem. Your domain is always going to be all real numbers. Okay? If you have to do it in intercept form, that means we have -infinity up to +infinity. And the infinity symbols always are unbounded because there's no end. It keeps going. All right? So, but my range though, this is the ones we have to be careful with. It's not dealing with any of the positive numbers, okay? None of the positive numbers are being used. Heck, it doesn't even equal 0. It's going to get as close as it can to 0, but it doesn't equal 0. but it's dealing with numbers from roughly 0 all the way to negative infinity. This is the part that gets a lot of people, especially if you're going to write out your range. If you're going to write out your range, it's not going to be negative, or it's not going to be 0, negative infinity. Okay? So we could write it out as y is less than 0. It's not going to be equal to, because it's not going to equal 0. It's going to get as close as it can. It gives you a reference point of what 0 is, but it's dealing with numbers that are less than. But if I were to write it out as a interval, there we go. Woo. All right. I always write the lowest number first when it comes to interval notation. My lowest number is actually going to be negative infinity, and it goes up to 0. But since it doesn't equal 0, both of them are going to get parentheses. Okay. Hey, Pong Champion. How are you? Okay. All right. How are we feeling? I'm going to work on end behaviors next time. I want to at least get this. All right. Excellent. All right. So you can follow, you can like, you can click away. That's perfectly fine. But I definitely just want you to understand that it's not to the point where it's super, super intensive. As long as you understand the algebra, which is you substituting your x values, and if you don't know what to do, just use your staple, -1, 0, and 1, okay? In fact, you probably don't have to do the 0 because your a value, your a value, which is right here in front, that is your y-intercept, okay? You don't believe me? Look at the graph. It says -2, here's 0, -2, okay? This said +3, here it is at 0, 3, okay? So if you want to, just get one that's negative and one that's positive. And if you want to add in another one, maybe it could have been, another one could have been a -2 instead of the +2. You can do that so you can see that curvature a little bit better. Okay. Okay, awesome. Yeah, I tried to keep it as simplified as it can possible. Tell me this is GAD or I'm never going to pass. Okay, well, here's the thing. As long as you, and this is for Brenda and Cody. So Brenda and Cody, the GED, every point or every question is not valued at the same rate. Now, this is huge. A lot of people don't understand this. You're going to have your arithmetic. Everyone can do the adding, subtracting, positive and negatives, fractions. You got that. Those are like 1 or 2 point questions. The thing that is going to help you pass is getting a lot of the graphing, equation of the line, finding the slope, knowing the difference, knowing the slopes of parallel and perpendicular lines, and system of equations. Those are 4 point questions. If you can get a good majority of 4 point questions and just get all your arithmetic ones, you're going to pass it. Okay, that's how you pass it. A lot of people are like, oh, okay, the algebra, okay, that's it. No, if you get the algebra, those are going to be like literally one question is worth 4 points. And you need, I think it's like what's the passing score now for GED? Is it 162? Please remind me. Okay. All right. So I'm going to save the end behaviors for the next time because I don't want to overwhelm people. That's why. Okay. Can I show the top of the page? Sure. Let me unzoom a little bit. Okay. Brenda Cole, did you hear? Cody. Sorry, Brenda and Cody. All right. So if you understand the difference between quadratic and linear, I think you're going to be fine. But the basics of exponents, like when you're multiplying, you add the exponents. When you divide, you subtract the exponents. If you can get factoring and anything dealing with the equation of the line, how to read the graph, you're going to be fine. Those are those 4-point questions. How long we'll be covering this? I need to catch this in the beginning. Yes. And then plus, remember, I'm going to try to put my replays on YouTube. Okay. All right. We're good. Really taking into depth with this stuff in school. And that's the one thing, because everything is rushed, and I loved how to have that discussion. Trust me, I was interviewed about this on Friday, but I'm going to jump onto this so we can get a little bit more before I get on my soapbox. Okay? I know, trust me, there is a soapbox. All right, so now let's get with this one. Let's see if I can zoom in a little bit more. All right, so we have y equals 5 times 2 raised to the x. Remember I said sometimes they'll put it in parentheses, sometimes they'll put like a dot, multiplication dot. Okay, sometimes they'll just put it together. All right, so we have 5 times 2 raised to the x. So what is my y-intercept? What will be my y-intercept just by looking at the equation? Okay, so Trash Skills says 5. Palm Champion 5. Period says 5. Period joined. Hey, period. All right. Okay, some people are not too sure or not too brave. That's okay. All right, so your first number, that is your y-intercept. Okay, so your y-intercept is when your x values are equal to 0, and then you'll see your y value. So the first point should be, this is 1, 2, 3, 4, 5, right here at 0, 5. So at least we know we have a starting point. So for us to get the other points, let me kind of shrink this down just a hair. And for us to get the other points, let's make a table. So we're just going to make a nice little small table, nothing too crazy. So since we already have the 0, let's use -1, or let's use, let's use +1. Let's use +1 and +2. And there's a reason why. So we're using 5 times 2 raised to the x. So that means we have 5 times 2 raised to the first power. And anything raised to the first power is going to be itself. So it's really going to be 5 times 2, which gives us 10. So the next point that we have is at 1, 10. Okay, you see how it's like a huge jump? Okay, so it might be going like this. And it's going to be really sharp. So if we do for the second one, we have 5 times 2 raised to the second power. Okay, so 2 to the second power, that'll give us 4. 5 times 4 will give us 20. So the point that we have next is 220. Here's 2 and 20. Woo, look at that. Okay, that is a huge leap. Well, I want to kind of see what's happening down here. So if I want to, I could, let's say to the negative second power. We can say that. So if I want to say negative 2, or I can say negative 1. We can do negative 1 and negative 2. So if I said negative 1, that means 5 times 2 to the negative first power. Anytime I have a negative exponent, that means I need to drop this into the denominator. So if I drop it, it's actually going to be 1 over 2 to the first power, which is 1/2. So 5 times 1/2, that gives me 5/2. But I know a lot of us like decimals. So 5/2 is equivalent to 2.5. Okay, half of a $5 bill is $2.50. So the next point that we have is negative 1 and positive 2.5. So here's negative 1, here's 2, here's 2.5. Okay, I feel like I need to go back to school to draw circles. It's crazy. So we have for negative 2, it's 5 times 2 raised to the negative second power. So that means it's going to give me 5 by the 1/4. Because if I flip this, it's going to be 1 over 2 squared. And 2 squared is 2 times 2, which gives me 4. So that means I have 5/4. Now 5/4, it looks like it's getting smaller, which it is. Okay, I was trying to split a $5 bill 4 ways. That's $1.25. So negative 2, we're at 1.25. It's about here. So as you can see, my graph is going to be gradual. I use my red. So it's going to be nice and gradual. And then it's going to shoot up like a rocket. Okay? Okay. So good. Negative 1 and 2.5. Good. All right. So this is how we're getting our exponential. So since we know our y-intercept is at 0.5, we can calculate it if you want. Anything raised to the 0 power is going to be 1. So 5 times 1 will give us 5. So that will give us our 0.5. So we know that my domain is all real numbers, because it's always going to be all real numbers. What's our range? And we can do it as an inequality, or you can do it as interval notation. What will be our range? So y is greater than 0, y is greater than 0. Okay. Are they right? Ms. Gardner's like, I hope so. I know so. Okay. Hey, Leela. All right. So our range is our y values. So it's not crossing the x-axis at all. So it's dealing from 0, but it's not equal to 0. okay? It's going to get as close as it can to 0, but it's not going to equal 0. But then it's dealing with all the numbers that are positive for my y's. And it keeps going on and on and on all the way to positive infinity. So we're going to say that our y is greater than, because it's going upwards, greater than 0. But if I wanted to put it as an interval notation, my lowest number is going to be the 0, because my highest number is going to be positive infinity, because it's keep going up. When it's going up, it's going in the positive. So since it can't equal 0, we have a parenthesis, and there's always a parenthesis with the inequality. All right. Okay, questions. Okay, questions. All right, so if you know of anyone that's maybe currently dealing with this, okay, currently dealing with this problem, this question, have a quiz on this next period. There you go, Pierce. So if you have any questions, this is the perfect time to ask it. If it's parentheses or bracket. Okay, good question. So if it includes it, okay, if it includes it, so if it does equal 0 and it goes to positive infinity, it will be a bracket. Okay, so if I had, let's say if I had, you don't have to write this part. Actually, I'm going to write it on here, because I don't want to visit my notes. So let's say you had a quadratic. I know, it's a little busted, but here we are. So it's including this point at 0, 0. So since it is opening up like a cup, that means I'm dealing with all my numbers from 0 all the way up to positive infinity. So I'm including 0 because it's a point that's on the x-axis. Whereas this one is getting as close as it can to the x-axis, but it's not crossing it. So this one would be y is greater than or equal to 0, because it's a point that's on the graph. So if I were to do the interval notation, it's including 0, but it's going all the way to infinity. Whereas here, it's not including 0. So if it's not including 0, it's going to be a parenthesis. If it's including a point, it will be a bracket. Well, I don't know when you're taking your test, and stop yelling at me. Keep that tone down. All right. Okay. So, yep, Pierce transformations. So, if you were to transform, okay, I can do this problem. Let me see if I can do this one here. Okay, equal to, greater or less than will be a bracket. Yeah, anytime it has an equal to, yes, it will be a bracket. Okay, I like rotating my graphs to the right 90 degrees to show students the y-axis to write the intervals. Okay. Yeah. Yep. Because it's almost like here. Like here is your x. So it's like, all right, here's your 0. And it keeps going all the way to positive infinity. Yeah, I like that. Thank you. It's like, it's so funny because when I used to do it on a whiteboard, I can't turn my whiteboard. So, yeah. Old school girl. Okay, this lady here helped me get 100 on my midterm. Oh, demand. Throw your money at her. You don't have to throw all your money at me because y'all can't live with me. Oh, well, thank you. Thank you. All right. So here's one that we can do with transformation. I think like Pierce, but everyone. So we have 3 times 2 raised to the x minus 2 plus 2. And you're like, whoa, we're already getting crazy. I don't understand. Okay, so Rosie, your range is going to be your y values. Okay, so your y values goes up and down. Okay, right now there's a boundary right here at 0. Okay, so if we can use, let me see, what was her name? I want to give her credit when credit is due. If you look at what Sandra said, okay, if I look at the graph this way, these are your y's. So I'm here at 0, okay, going all the way to positive infinity. So it's not equal to 0 because your graph is coming as close as it can to 0 without crossing. All right? So if you go from 0 to positive infinity, that's going to be your range. So that means your y's are greater than, not equal to, just greater than 0. Okay? Because it's going all the way up to positive infinity. Okay? So make sure you give Sandra a thank you. Okay? Give credit when credit is due. All right. Now, when we're doing the transformation, so we got a lot of little things happening. So with this, you could still do your 3 points. You can still do your 0, your -1, your 0, and your +1. You can still do that. Now, anything that's happening, let me see if I can underline or highlight. Anything that's happening in with the exponent, right here, that's dealing with your x-axis. Okay, so I'm going to write it up here. Okay, so you're either moving left or right. Okay, so you're either moving left or right. Now, if it's negative, you're moving, or minus, you're moving to the right. If it's a plus, you're moving to the left. You always do opposite what you see, okay? Because the original formula will be x minus your h. Over here now, that is your movement up or down. So this is dealing with your y-axis. Okay? And you're either going up or down. If it's positive, you're going up. If it's negative, you're going down. Yeah, no. All right. Okay. So now, you still have your y-intercept. Okay. But there is going to be some movement. So if you want to, my thing is, and this is just me, everyone else have their notion. If they said, okay, what happened to the graph? I know by looking at this, this went to the right 2 units, and it went up 2 units. Okay, so that's what this is saying. So if wherever I start, if I normally would have started here at the 3 because I didn't have any movement, but since I have extra bits and pieces of movement, if I start here at 3, that means I went to the right 1, 2, and I went up 1, 2. But the best way to kind of make sure, sometimes I just look at the table. And I'm going to see if I can squeeze all in there. Okay, yeah, this is going to have to be my last example. Not because I'm scared, it's just because I have to go to my next client. All right, so what would make sense here? Would be a 2 would make sense here. And I'm going to tell you why in a second. All right, so now I'm going to substitute. So I have 3 times 2. If I'm plugging a 2 in for the x, 2 minus 2, that will give me 0. 2 raised to the 0 power, that will give me 1. 3 times 1, well, that will give me 3. And when I add the 2, I'm going to get 5. So I have this point, 2, 5. So here's 2, here's 5. And that's very interesting. The reason why I say it's very interesting is because if my original starting point is at 3, and this is telling me I need to go over to the right 2, 1, 2, and then go up to 1, 2. Look what we just graphed. Okay, that's what we just graphed. Now, since this is this is going to be my asymptote. When you have your constant is going to be your asymptote. So now, because we moved the graph from x-axis, we moved it up to 2. So that means we also moved the asymptote that was the x-axis up 2 units. So this is your asymptote. That's your boundary line. So that means your graph can get as close as it can to that boundary line, but it's not going to cross it. And the reason why, because we went up 2 units. All right. If I plugged, let me see what else I can use. I mean, I'm still going to get fractions no matter what. If I plugged a 5 in, I could plug a 5 in. That'd be too much. If I plugged a 4 in, we can do that. We could just do it evens. So if I plug the 4 in, there's a reason. I'm just trying to kind of get away. Well, we can do a 3. Did someone say 3? I know. I just saw things moving around. So we can do a 3. Let me do a 3. So that means I have 3 times 2 raised to the 3 minus 2 plus 2. So 3 minus 2 will give me 1. 2 to the first power is 2. So now I have 3 times 2, which gives me 6. And 6 plus 2 gives me 8. So I have another point, 3, 8. So here's 3, and here is 8. Okay. Because if I try to do 1, it's going to give me a fraction. And I know how much you guys love fractions. Being sarcastic. So So if I wanted to do with 4, sorry, that means I have 3 times 2, so 4 minus 2 plus 2. 4 minus 2 gives me 2. 2 to the second power gives me 4. 3 times 4 gives me 12, plus 2 gives me 14. So I have my 4 and I have my 14. Because now I can see my curvature a little bit better. Okay? Well, let's tackle with the negative. So I'm going to go with when my, let's say with -1. Okay, we're going to be a little funky with it. So I have 3 times 2 with a -1 minus 2 plus 2. I'm going to show work on this one. So -1 minus 2 gives me a -3. So you have 3 times 2 to the -3rd plus 2. You cannot have a negative exponent, okay? So you have to flip it. So it's actually going to be 3 over 2 to the 3rd, which gives me 8. So 2 to the 3rd is 2 times 2 times 2. That's where the 8 came from. But I need to add it. Add 2. But 2 is a whole number. In order for me to add a fraction, I need to change this whole number with a common denominator. The way I like to figure out what my numerator is, because sometimes people are not strong with their division, but they're pretty decent with their multiplication. So you would take this 8 times the 2 and put my 16. Because 16 divided by 8 will give me 2. So now I have a common denominator. 3 plus 16, that gives me 19. 19 over 8. So 19 divided by 8, it's definitely more than 2, but less than 3. So we're looking at when my x is -1, here's 2, here's 3, but I think it's right about here. It's like let me do that. 2.375, okay? Because sometimes looking at it in decimal form will kind of give you a rough idea of where to put your line. So now I really can see it. So it's getting as close to 2 without, we're going to pretend that's straight, without crossing crossing at y equals 2. Okay. All right. Okay. So where is he? Pierce? Pierce. Okay, so Pierce, are you okay? Are you alive? Is your brain still intact? All right. So when it comes to the transformation, when you're looking at it, what is with the exponent? That deals with your x-axis. So it's always opposite of what you see. And we even proved that, okay? Your value at the end, that deals with your y-axis. And if it's positive, you go up. If it's negative, you go down. So normally, if you don't have any of these transformations, like say if it was just 3 times 2 raised to the x, that means your asymptote is going to be the x-axis. But since we had to raise up 2, my asymptote is always going to be your constant. Okay, the constant that you have out here, that's your asymptote. and my asymptote was at 2. So if you want to find your points, you can do one of them with the transformation or do a table. Okay, do a table to see if you can figure out the curvature of it. Okay. Questions. All right. So this is basically graphing. Okay. There is a little bit more to it. So like if I do real quickly, but not doing the table, just so you can identify the transformation. So for this one, zoom, if I did the transformation of this, my starting point would have been at 4, but this is telling me I need to move 1 unit, and since it's minus, I'm moving 1 unit to the right. You always go opposite of what you see. Then I'm going to go down 2 units. They're saying that my asymptote is going to be at -2. So this is telling you movement, and it's also telling you your asymptote. Where is your boundary? What can't you cross? It's almost like you leaning up against a wall, okay? If it's a solid wall, you're not going to just go through it, okay? That's going to be your boundary. All right? Okay? So the transformation is, and then this is going to be decay because my B is between 0 and 1. All right, so we're dealing with decay. The transformation is going to the right 1 and down 2, and my asymptote is going to be -2. So I can't say my y-intercept is going to be 4. It can't be because of this movement here. If that movement wasn't there, definitely my y-intercept is going to be 4. But because of this movement, we have to do the transformation to find our point. Alrighty? Okay. Today was a little short, but I will be on tonight. Probably shooting for like 9:30. I have a couple of meetings I have to attend to on top of tutoring. This is a busy time for tutoring. So if you do need help with any of your stuff, I'll promote all my stuff. If you like this notebook, I did design this math notebook myself. So we can get our formulas down, we get our work down, we get our steps down. It is available on Amazon. Just go to my website in my profile, and there's a link that takes you directly to either this one or the one, this is starting to get popular, or this one that looks psychedelic, and there is a third one. All right, but I do have to get going. But if you have any questions, do not hesitate to contact me. We're going to be doing some more with exponentials, and soon enough, we're going to be doing exponentials and logarithmic all this week. Okay? So I will see you later on this evening. It's like around 9 or 9:30 p.m. Eastern Standard Time. Okay? So I'll be then. All right? Okay. Oh, well, thanks, Britt. Any tips on the Algebra 1? Algebra 1, there's a lot of stuff. Okay? Right now, I have to get going because I have to tutor. All right? So I will talk to you guys later on this evening. Take care. Bye now.